This tutorial is going to be highly illegal because I'm going to show you how to make pot in Blender. And when I say pot, I mean a pot like this. I don't know what you were expecting. Basically, this is a completely procedural pot that is controlled by this curve. So here, I'm making like different kinds of vases. You can get as detailed as you want. You can change the shape, etc. And it's completely geometry nodes based. Now, the idea of this is going to be we're going to make a curve, kind of like a profile curve defined by this shape, and then we're going to rotate it around a central axis, which sounds simple, but as you can see, it is not. So what you're going to learn in this tutorial is how to make a lathe. That's what we call it, a lathe modifier. So let's get into it. Starting off with geometry nodes, take the cube and make it a geometry nodes group, delete the cube, and like I said, we're going to need to do two things. First of all, we're going to need to make a profile curve. So this is going to show kind of the outline or the silhouette of our vase. And then we got to rotate it to kind of make it three-dimensional. The first part, making the profile curve, is significantly easier. So what I'm going to do is I'm going to use a mesh line to do this. Reason being, it's just going to be a series of points that we can push to the side and manipulate. So I think that's going to be pretty easy. So I'm setting a line such that the endpoint is at 1, 0, 0, 1. So it's 1 unit tall, simple to visualize. And I want procedural control of the count, the number of vertices, because this is going to end up being kind of one of two resolutions for our lathe. So we have the profile resolution and the rotation resolution. Either way, I want to make this thing a custom shape, so every time we make a modification to the position, we use a set position node. If I could make a shirt, it would say, always use set position. You know, there really isn't much more to life. Don't think, don't struggle, just set position. What do I want to do with set position? Well, I want to alter the position, so I'm just going to use the standard position. How am I going to alter it? We're just going to shove it over to the side by either adding or subtracting a custom vector. So what have I done so far? We said make a line. We're saying reposition the line based off the position, but we're going to nudge it. We're going to subtract it, okay? So what are we going to subtract? I want to push it on the x-axis. So I want a function depending on the x-coordinates. So let's do an RGB curves. You can also do this with a custom function or with a color ramp, okay? RGB curves is shifting everything over by 1 because we don't have an input for this RGB curve. So it's just saying make everything 1 unless we change the color, right? So we need to give this an input. And I want to say the input is as we go up the line. So as we go up the line, kind of use this graph, right? So the bottom point is this one. The top point is this one. It'll make sense in a second. How do we know how far up the line we are? Well, we can either use the z-coordinate or probably much simpler is the index, right? Because remember, this line is composed of a bunch of points, as you can see right here, index 0 through 9. Or we can make it 0 through 19 if we use 20 points. So I'm going to take the index and I want to divide it by not just 10, but whatever number this is, right? So we can set it to 15 if we wanted to. We could set it to 30. I want it procedural, okay? So we're taking the index and dividing it by 30. Therefore, the index, instead of going from 0 to 29 or 0 to 30, whatever, it goes from 0, divide, it goes from 0 to 1, which is what RGB curves accepts. So long story short, you can see when we connect this, we make this triangle shape, and it's making this triangle shape here. If I do this, it's going to do it. You almost want to rotate this graph 90 degrees in your head, counterclockwise to see it. But you can see I'm adding detail, and I'm making a custom profile curve, and this is the resolution of it. So it can be low res or high res. So I'm going to go with something simple like this shape right here. So we're done with the profile curve. This is part 1. What I want to do now is to make this a vase is almost if we rotate it, again, this is called a lathe. And it's an actual machine in real life used to make stuff. But in terms of a modifier, we want to rotate every single point on here. Now, we don't have a lathe node. You could do this with modifiers. I think probably the way to do this is, I wonder if, I know there's something called like a screw modifier. That will do it. but we want to do it more complicated. So basically what we're doing is we're making the screw modifier custom. And you ask why, and I say, I don't know. Well, we're just doing it just because. So to make the screw modifier, we're going to do this in a weird way. What I'm going to do is I'm going to make a grid. This grid is just going to be a plane that we want to transform into the shape of the pot. And you're like, what are you talking about? Why are we using a grid to make the pot? You know, it just seems weird. Well, long story short, we don't have a way to do this lathing, so we're going to make a function that maps it to here using the information from back here. So you'll see. What I want to do is I want to make sure we set these vertex numbers to very specific numbers. So we have an x and a y, so we're going to need 2 parameters. And you guessed it, we're going to be using this one as, I guess I need to think about it, either the x or the y, we'll see. So I'm going to connect one here, I'm going to connect one here. Let's make this like 50. And the indexing really matters because we're going to use the indexing to create this function. So let's visualize what's going on here. I'm going to delete geometry based on the index, and I want to know where it is greater than or equal to some number. Why am I doing this? You can see as we're increasing this, we're kind of generating the grid line by line by line. And kind of the key insight here is that it goes up first and then across. So up, across, across, kind of like an inverted Mandarin. You know, it's written top to bottom. This is bottom to top. This is important because that shows the indexing kind of does this weird zigzagging thing. So first, the indexing goes up this high by a custom number of units, in this case 50, and then it's going to do that for 30 iterations, 30 rows. So it's going up 50, 30 times, okay? If we set this to 3, it would be much simpler. It goes 1, 2, 3, 1, 2, 3, 1, 2, 3, you know? But that's pretty important, okay? So it's going up by 50 units, 30 times across. So what I'm going to do is I'm going to take the first line. Let me just show you again. I'm going to take the first line, so when this is equal to 50, so the first 50, and I'm going to map it to the profile curve, the one from before. And then each row, we're going to map to the profile curve, but slightly rotated over and over and over again. So either way, we're making our lathe kind of iteratively is the idea. And I know it's complicated. But I'll show you how to do it. So first order of business is we want to map this first row to our profile curve. Well, how do we do that? Well, we already have the positions here. Wouldn't it be very simple if we could just transfer that? So I'm going to use this as the source geometry, the set position. We want to transfer the position. And we're going to do that by indexing. Like I said, we're going to be using the indices. So, long story short, I'm going to get rid of this demo stuff. If we take the grid and we set position, every time we want to alter it, we're going to use the set position. If we alter it and say map the position to this transfer function, you're going to see it's going to look weird. But you can see it's kind of doing the profile curve, but then kind of connecting it. And that's because there's this like grid in the background. So you can see it's doing this weird kind of thing. But the way I want you to think about this is the first row of the grid is being mapped here, and then the rest of them do some stuff. So the way that we can do this very simply is we could say only remap the first 50 or so points. Okay, so I'm going to run an index, only set position for index less than or equal to our, well, this is where rows and columns matter. So I think it's the number 50. Okay, so the way this is going to look is we have the profile curve, as you can kind of tell. And then the rest of it is going to be down here. So it's almost like we took the grid and only transformed the first line. A good way to visualize this, just so you understand, because I know this is confusing. A good way to visualize this is the grid, and we map the first line, just like that. Okay? Now what we want to do is use this information, this first line, to now go down each line of the grid and say do it, but rotate it a bit on the center. Okay? So we're going to split this up into two set positions. We are going to now set position based on this first row. So I'm going to use a node called field@index. What this does is it tells us at a certain index, and we care about the indices that create this profile curve, tell us, and we can use a custom field, the position. So field.index is going to tell us the position for the indices we care about. Now, this is where it gets super, super confusing, so just try to follow along. Each row is going to be slightly rotated from the previous one, so they're all kind of dependent on the first row, okay? Each point on this grid is going to refer to kind of its matching point here. So this point right here on this row is going to refer back to the first column. And this point right here would reference this one. In other words, we want to look at the position of the corresponding point, and we know the indices of that. So kind of the way to actually do this is we're not just going to take the index, but we care about the index of the first row. So we're going to do it modulo. We're going to do it modulo. I'm going to find modulo. Modulo the number of vertices. So again, if number 100, well, let's say there's 50 entries per column. If we look at entry 51, we take it modulo 50, and that maps to 1. It's kind of like we're going around a clock, sending everything back to the first line. I would look into modulo if you don't know what it is. But that's kind of the idea of having these lines refer back to their corresponding element, okay? So if we now do this, let's see what happens. Well, it seems to kind of disappear into the oblivion. We can think about why that happens. By the way, we do need to set this up before we kind of look into this. We do kind of need to set this up so that it's not doing our initial profile curve, because it's going to be dependent on the thing. There's kind of circular logic here. So for the first set position, we care about the first column, and then for the rest, we're going to do everything greater than. So we're going to set position to the rest. So we're kind of splitting it up into two categories. And you can see it's kind of this collapsed thing, like we can no longer see the profile curve. It's all kind of gone wrong. Don't worry, we can still recover this. What we get is, if you want to imagine it, is we get kind of it's not here, but we get the profile curve, and now all we need to do is we need to remap each column to be slightly rotated. So how am I going to do that? Well, if we look at the grid, the original grid, we kind of have this profile curve, and I want to say for each column, each corresponding column, each point on this is going to refer back to the original column. So what I'm saying is, this one is already mapped. Take each corresponding column and map it back using the same row, because we already have that information baked in. I know it's confusing. This is kind of the hardest part of the video conceptually, but here's all we need to do. We just need to rotate it. So first of all, let's do a vector math rotate, and you can see as we rotate, we kind of get our profile curve, as you can see, right? Let me actually zoom out and do that again. We kind of get our profile curve. But what we want to do is for each column, it should be rotating a bit more, a bit more, a bit more. So here's how we're going to do it. We're going to take the index, and we want to say each column gets a number. So column 1 gets number 1, or actually 0. Column 2 gets number 2, 3, 4, etc. We can do that by taking the index and dividing by how many elements there are in a column. So again, that's going to be 50 in this case. And then, so we're getting 0 to 1, 1 to 2, 2 to 3 on each column, and then we round up or down, doesn't really matter. So that now each column has a number. Connect this to the angle, and you can see it's kind of giving the right thing. It kind of looks like the screw modifier, but it really looks like the screwed modifier, because this doesn't look correct. Basically what's happening here is we're overextending our rotation. So if I make it a bit tinier, you can see it's kind of working the way you'd expect it to. But if you overextend, it gets weird. So the question is, what is this magical number we have to multiply by? Because again, each time our angle is increasing by a little bit for each column. Well, let's think about it. Our angle increases each time. How many columns are there? Well, there should be 30 of them. This is our other parameter. So if we take these numbers, like 0, 1, 2, the column numbers, and divide it by the total number of columns, I know it's getting crazy, this should now be going from a rotation of 0 on the first one, and then rotating, rotating, rotating until we get a rotation of 1 radian. And how many radians are there in a circle? If you don't know what radians are, they're like degrees, but the mathy version. There's 2 pi of them, so let's see. Let's see if that's correct. We're going to multiply, keep going around, keep going around, keep going around, and we kind of converge. By the way, I think technically, since the column start at 0, you want to subtract 1 from this. So there are 30 columns, but it starts at 0, so you subtract 1. We wrap this around, wrap this around, wrap this around, and you can see it kind of connects at this magical number, 6.28, roughly, which happens to be 2 times pi. And this is what's going to make it connect exactly, okay? And now, and by the way, this extra point, like I said, we're going to talk about, but you can see we can now control the resolution of both kind of the profile curve. Let me actually reduce it a lot. Probably not that much. You can see the more we increase this, the more it kind of builds up until it gets kind of high resolution. So I'm going to do it 60. And then the resolution of this is going to be the resolution of our lathe. So I'm going to set that to 60 or something like that. What we can do now is where the thing connects is we want to merge them into a single geometry. So I'm just going to use a merge by distance node. So that's going to connect the seam because they're within this distance of each other. And that will also connect all these points down here at the pole. And let's just kind of make this a solid. So I'm going to, that looks horrible. I'm going to extrude mesh just by a little bit. Something like that. So it actually has a lip to it. And is this kind of hollow? Yeah, we want to join this with the original so it has both this inner shell and the outer shell plus the lip. So this is going to give it both. And then we get a merge by distance again to connect them. Run a shade smooth. I know, we're going crazy. And this is how we make our custom screw modifier. Again, the advantage of this over, geometry nodes, over the modifier, is that we have control over everything, and we can customize our profile curve using a procedural approach. So it's kind of like a weird tutorial. And by the way, I'm not 100% sure about, I think this is kind of an indexing issue, this one right here. So one of these we either like add or subtract 1. I'm not exactly sure which, but if anybody knows in the comments, maybe it's this one, it seems to have fixed it. If anybody knows in the comments, do mention it. Well, that seemed to fix it. Okay. I'm not going to question it. But yeah, I know this tutorial is kind of all over the place. This one was kind of difficult to explain. But you can make custom vases just like that. And I think you should be able to add a bevel. You can see that kind of sharpens the edge right here, especially if we have more segments. So this is before and after. You can mess around with that. But, custom screw modifier. We can make a duplicate of this, make it its own geometry nodes group, and do something a bit different. Something like this, and like that. And you can even move the bottom point. Well, I guess there are reasons to maybe not do that. But you can make the bottom hollow if you wanted to. That's what this one does. Or you could have it all the way at 0 and it connects. Either way, I feel like this tutorial is messy, so I just want to say at the end of all of these videos are brought to you by my Patreon. There's a link in the description. If you just want to download the geometry nodes group without like this messy explanation, you can download it there. There are 3 benefits that come from your patronage. 1, you could watch tutorials early, so you could have seen this tutorial a day early because I now have a back catalog. 2, you can get the blend files for this and any other blend I've made over the last 3 years, I think over 3 years. And thirdly, exclusive tutorials that I try to make once a month or sometimes more often. Whatever. I feel like we did it. And I just want to mention, by the way, let me just kind of do this at the end while we have like the credits rolling and all that. All of this was a transformation from the plane. So I'm just going to mix back the original position for this. And remember, we did the set position in 2 steps. So I'm going to mix the position here as well. And you can start seeing it's doing some weird something or other. If we make a single parameter for these, you can see this takes the plane, which is kind of a cube when you solidify it, and it turns into the vase. That's what we did. We made the math function for it as kind of a conclusion. Either way, thank you for watching. I'll see you on the next one. Peace.